Hi guys, so you've probably seen the auction video already. This is one of the bits of equipment from that video. Just a quick thing, and I know I've said this before, with over 28,000 views on some of our videos, we've still only got 850 odd subscribers. So if you're watching our stuff, click that button please and get subscribed. If you subscribe, we know it's worth the effort. We can do the videos, and obviously if it's working for us, then we can get more interesting stuff to look at. There's quite a lot in the auction haul. We will be going through all of it. Most of it is test equipment which I want to put back into use, and as I said, this is the first one that we're going to look at. This is an LCD frequency meter. These were originally made by Thurlby Thandar. This is an RS Components badged unit, but otherwise it's identical. These were really common in schools and colleges of the era, and indeed the labs that I worked in, the labs that I trained in, we had the full set of these. You have the LCD frequency meter, you have the multimeter, which we'll look at on another video, you have a pulse generator, a function generator, and there is even an oscilloscope in this format, which I believe either Dave Jones or Radium Black have done teardowns on, and I'll try and get a link in on that. This one does nothing, it doesn't power up. We have a unknown DC barrel connector on the back, which I'm not brave enough to touch. We have a lot of weight here, and that led me immediately to suspect these are not easy to get apart. Let me grab a spudger. This led me immediately to suspect there were batteries in there, and indeed there are. I have no idea how to get into these. These are quite elderly Everready batteries in here, and they are soft. So, you know, there's a lot of corrosion going to be in there. So hopefully it's salvageable, but let's rip into it. Let's get these feet off, get the screws out, and we'll see what you can do. I don't know what the purpose of this battery door is, because you can't get that battery connector out of there. So can't use my little electric screwdriver because there's no room. So we will just pop all of these screws out. That isn't a screw, that's an adjuster. Different audio setup as well. We are using stereo microphones today. They are spread out nicely across the bench, so should get better sound coverage of everything. This is not moving, I'm not sure why. Oh, that's because we're doing it the wrong way. So the top comes off like that, and we've got a screw on this end that isn't actually out. I think these are machine code screws into brass inserts, and trying to work out why we're not moving. Everything's now falling out. Our DC jack is what's holding us up, and it's just slid in. Do we have a date on this? No, we don't. I like that even the label has got an RS part number on it. So we are in. Let's just grab all of our screws as we fall out, and you can see this is all discrete logic stuff. I am seeing some signs of battery damage on the board. That's not good. I really want to touch that. So looking at it, actually no, I don't believe that to be the case. I was going to say, it looks like you can pivot it out and slide it out, but this battery connector was quite obviously designed to lock in there. I don't have as many screws as I'm expecting. So four screws and a long one. I have 2 screws. Oh, there's one there that's escaped. They're just M3 machine screws, so that's not a problem if we've got any missing. Right, let's centre you up and bring you down. I'm not going to comment about it looking dark, because I know it's not, although we have got a lot of reflecting coming off of that, so I think that's going to need cleaning, and we're going to need to see what's underneath that, so I will take that out anyway. We'll get to the batteries in a second. but this should hopefully drop some of the glare down. Right, first things, we've got signs of leakage down here, signs of leakage around here. So this is all 4000 series logic. I would imagine this bears more than a passing resemblance to the Maplin frequency counters of the same age and vintage. But yeah, we've got 4011, 4070, 4011, 4013, 4013. We have a 4518 here that is out of its socket. 4518, 4518, 4518. So those, I think, are the counters. Let's just, you can probably hear some of those going crunchy. We've got something in the end here. 407 something. Just get all of these pushed in. A couple of these did go in. I think before we go any further with this, we will get in on the back of those switches. Do the one with the tube on the end. So, right, I'm going to pause you for a second. I'm going to go grab some gloves because I don't really want to touch these batteries. Right, let's... You know what, part of me is thinking that we shouldn't even try and rescue this. So, our springs are gone. The batteries are spongy in places. Doesn't appear that anything has flowed down the wiring. So what have we got here? 3, 6, 9 volts. We can probably do that with lithium ions easy enough, but this is going to run on 5 volts. So right, I think, no, I'm not going to have to pause you again. I've got a pad just here. I think we're wave goodbye to those. That's solid core wire. Can we see a best before date on these, or a manufacturer date? I don't think these batteries have been made for a long time. So they are ever ready gold seal, which I remember seeing. I don't really want to mess with them too much, but I am really quite curious. Can I even get them out? I suppose they've got gloves on. What's the worst that could happen? So yeah, I remember these ever ready gold seals. Made in Britain. Oh, that's not the case anymore. I can feel that the case is just gone on them. I don't know where the use date would have been. That might be it there. Nope. They're gone. I don't think there's any point in doing anything with them. Right, let's spin this around and have a quick look at what we've got here. So, damage to the board. I'm not actually really seeing any. I don't know that there's any benefit to running this off battery, you know. We've got an auxiliary power out. How strange. I wonder what voltage it actually is running on. So we've got 9 volts coming from the battery. We've got the battery eliminator wiring on there. Can we take it out? Is it worth taking it out? I say we do, because it'd be nice to check the underside of that board. I need to think of a way of testing this as well, because I don't actually have a working function generator. They had a full set of these and I was bidding on the entire lot, but unfortunately I didn't get them. There's another screw somewhere. Is there another screw, or are we just stuck? No, it definitely feels like we're missing something. I don't think it's the LCD, because that looks like it's free moving. Nothing in the corner here. We've got all our screws out for definite, haven't we yet? I think that battery may have leaked through to the bottom as well somehow. Aren't we just stuck in? We're just stuck in the front. That doesn't look too bad. Right, hopefully there's no horror stories on the back here. Absolutely not. Right, so quick look here. So our battery negative, let's zoom you in. Oh, wrong way. I don't know how clearly you'll see this. Where's my pointy stick? No idea. So our battery negative comes in here on these pads, and one of those wires is the orange that goes straight up onto this barrel jack. Actually no, you know what, it's just as well I checked that. So it's actually the battery positive goes up onto the barrel jack, and there you can see in that jack the contact. So when you push the battery in, push the barrel jack in, that opens, disconnects the battery, and everything goes through. So we've got centre negative on here. That could have been bad. So what do we do with this? I don't really like having centre negative equipment around. I don't think that I'm going to run this off batteries. Do we reckon 2 lithiums would be enough? Should we get 2 lithiums and see what happens? Oh, I think we will. That wire doesn't look wonderful. If we put 2 lithiums in here, we're going to need a way to charge it as well. Let's zoom you out and go grab 2 lithiums. So we have 2 tested lithium cells there. Let's just turn this on. There's no way you can see this. Chuck our batteries together and just see if we get any life. I don't know that they're going to contact that well. Would it work on one? No, I doubt it will, because this will all be 5-volt logic. You know what? It does. Although it's giving us a battery low, which almost certainly means that 2 is going to be plenty. Yep, that's up, no battery low. Right, what we're going to do is we're going to convert this to lithium. And it's going to be a quick and dirty conversion. So we're going to use 2 of those. Oh, I've just dropped something on you, sorry. I want to reverse that battery jack so it's the right way round. It's going to be me using this, so I'm not. So if I put that battery jack the right way round, then it's going to cause us problems other ways. So we would need to. You know what? I'm going to leave that jack alone, because it's actually a weird. Don't know if you can see it. It's a weird size jack, so we're not overly worried about that. Now, we had 2 screws going through this plate. That one's in the right place. That one isn't, but we could, in theory, if we use those 2 screws, go on like that. Which, it would be a faff, but it would mean our batteries are actually changeable without opening the thing, which, given I'm putting no charge control or anything in here, is probably a good thing. Soldering iron is on. I put all my soldering gear away. So we need to join because that would be my preferred way of doing it. Maybe we'll do something interesting with it. So we need to join these two up here. What I'm going to do is these horrible solid core wires, we'll just get rid of them. I don't know why, but a lot of electronics equipment of the time seem to use internal solid core wire, which is sometimes not a great idea, because solid core wire after relatively few flexes will fail, whereas stranded copper tends not to. And we'll put some heat shrink over this as well. Pause you again, and we're back again. I'll just zoom you in, get you off of the sign, wet my bit. A colleague of mine was asking me unleaded versus leaded solder yesterday, I think it was yesterday, and asked me, you know, he was soldering some LEDs together, which should he use? And I have to say, and I know that this is going to cause controversy, can I use a smaller one on that? I think I can. That for what he was doing as a fairly newcomer, what I've said to him, that as a newbie he would be better off using the leaded solder. It flows better, you're more likely to get a better joint than you are with the lead free stuff. It's been an ongoing thing through the electronics world for quite some time. If what you're doing is going to go into the outside world, sorry, I've been out of frame for all of that. So, as I say, he asked me about leaded versus unleaded solder for what he was doing, and my reply is quite simply, leaded solder wets better, it makes better joints. For someone that's new to soldering, you've got a better chance of getting a joint that's going to last. So absolutely use the leaded solder. It's a discussion, that was stupid. It's a discussion that's been going on in the electronics industry for some time, and there are quite a lot of people, myself included, that believe that the increase in joint failures, dry joints and problems with motherboards are all down to this. And indeed I think the industry has said a number of times that the problems are down to that. So there we go, there's our little battery pack. What I'm going to do, I think, is I'm going to screw one of them down. We'll put this back in the base now. No, we're not. Sorry, I'm just trying to work this out in my head. No, we need to sort these out first. Yeah, so there's been a lot of talk in the electronics industry about failures caused by unleaded solder, and I think it's more or less unanimous that it was not an optimal solution. So, well, that was most definitely elderly solder. So I'm just going to pop this battery positive lead through. I don't know that you can see me, so we'll just pop that through like that, and then we need to get this negative gone, which is over there. Trying to work out which connection I want. Not that one. I'm in the wrong place, that's why it's there. Oh, I don't miss that smell. We'll find a date in a minute. There we go. We in? Yes, we are. Right, that power out jack, I'm not sure it's its function. I am half tempted to knock it on the head, but we'll leave it for now. Right, we should be able to try and put this all back together now. So that's our battery area there. Another option would be to take the DC jack off altogether. And I mean, these aren't amazingly high quality bits of kit. They never were. They were more sort of school and uni, as I said, type equipment. Whatever that stain is on that is not wet. So if it is battery acid or battery electrolyte, then it's long since dried. I don't see any sign of any damage on any components. I'm out of shot again. But yeah, as I say, the build quality on these was never amazing, and they're good. They're sort of good enough, and for what I'm likely to use this for, I'm not that worried about it. I'll put it up against my scope, which I know is accurate, and use that for a comparison. But I don't think we'll go any further on it in that manner. Right, we don't actually reach the hole I was hoping to use, but we have these other holes that were in here. Let's just, yeah, we don't reach anything. Part of me is tempted actually to leave that loose, because at least that way we can take it out the back and deal with it. So maybe what we'll do is I'll put this together again once I work out when I've put screws, and we'll glue those battery what do you call them, battery clips together, and keep them separate. How could we do it so they can't cause any harm? It looks like they are actually semi-retained, so what we'll do is we'll pack some foam in there with them. Let's just chuck some batteries in and see what we get. That looks good to me, so I don't think there is any way of seeing whether it's actually doing anything on the bench without anything. Our reset button is now stuck, so we've got our high frequency input, low frequency inputs, time average. There we go. Right, okay, that's what we wanted. We've got our gate flashing now, so we are doing something. Can I deliberately introduce some noise? Is it that sensitive? We're on high frequency. Yes, we can. Go on to low frequency. Back to high, I guess. Yeah, so it's obviously doing something, so I think that is a success. Now obviously we're going to have to well, certainly I'm going to have to watch this doesn't get left on and things like that. The battery low should come on long before these are a problem. So yeah, when the battery low comes on, we need to stop using it. We've got no protection on here, so if it does get left on, it's going to kill these batteries. Nothing in there feels hot or unhappy. Let's turn the soldering iron off. Right, I'm going to stop for a second, warm the hot snot gun up, and we'll make this pack out of these. And bear with me. I'm going to fire the hot snot gun up. We'll make a pack out of these. I've got plenty of foam under the desk over there, so we can foam pack this, and then we'll put it together and call this one done. I think I might just give that a little bit of love, because it feels, it shouldn't, I don't think it's a latching one. No, it's not, so we'll give that a bit more love. But yeah, right, I'll go get some hot snot. Right, while that's walking, while that's warming up, let's reassemble this. So we'll put those batteries out to one side for a second. Put our bail back in. And we do appear to have most of our screws now. So you can see we've got a little bit of padding here, but obviously with lithium ions I'd much rather have a bit more. What I may do is we'll stick a label on this. At the moment it is really only me in here using this equipment, but as the business is growing quite rapidly now, there may be call for someone else to use it. So I suppose there's another thing, just because you use one piece of equipment, don't rely on yourself to remember that you've modified it or done something to it, because it may not always be you using it. So we'll just spin these back in. Yeah, so what I'll probably do is stick a dyno label or something on here just to say, you know, lithium ion pack installed, don't run it flat. And I just feel uncomfortable about that DC jack, so I may actually hot snot that DC jack. Or have I got something small here that I could hot snot over it? Possibly. I'll just put a sticker over it, really, couldn't I? Right, so we don't want anything going further back in there than we have to. So this is what's called pick and pluck foam out of pelly cases. And it appears to be just the right size to sit in there, and then our battery should sit in there quite nicely, quite safely. So we put them back to back? I think we put them back to back. Yeah, so it's pick and plug foam out of pelly cases, and I never throw the offcuts away because it is such useful stuff. So what I'm doing now is just pulling the batteries out. They're not easy to get out of these things, and I know I'm off camera. And what I'm going to do is glue them back to back, but where I've got the hole there for the retaining hole down there, we'll try and actually get the glue through that retaining hole, and that gives us a nice solid pack, and we'll just glue that back there as well. I need a coffee as well, so I'm going to get this one done, and that is the first one of this lot done, and then I think we'll drag the multimeter out next. The multimeter has no batteries, so it's probably going to be amenable to the same modification. I don't think I've got any more of these though. I might have to scrounge around. These got used in all sorts of little projects around the place. There we go, we're warmed up now, so we line ourselves up, lots of hot snot, and bang them together like that. And the glue has gone through that centre hole there, which is good, and we'll just glue that down so it can't become a problem. Glue my gloves to it. Just a little bit more glue in there. I think the PTC type heating element in this glue gun is not great, because it seems to get quite hot sometimes. There we solid, yeah. And then just for good measure, straight down the middle. Turn that off. The other thing with lithium ions like this is you can put them in the wrong way. The pips, because these are designed for making battery packs and not really designed for consumer use, the pips are not that obvious, and they certainly will not stop you from putting a battery in backwards. Let's just make sure we're still alive. We are indeed. So if we tuck our battery in there now. So yeah, the pick and pluck foam, as you can see, it's little little, sorry, pick and poke foams, you can see it's little squares. So if we pull off 2 squares there, and we can just chuck one in there and one in there, and that will keep our battery nice and snug. And then that goes on there. As Dave Jones would say, don't know if you can see that, made in the old dart, it's made over here. So there we go, that is now ready to work. Because this is a hardware power switch, as in it actually disconnects things, I'm not worried especially about it flattening batteries, so I will keep an eye on it. But that one's done, so I guess the next one now is multimeter. Anyway, hope you enjoyed. Remember to click subscribe and support the channel, and see you soon.